YouTube, and welcome to the second episode of Operating System Development Series provided by the Iknow channel. If you have not watched the first episode yet, you can find the link in the description below. Also, you can find the source code used in this tutorial in the description section below. Don't forget to subscribe, and let's get started.
So hi and welcome again. To start up, I already created the files here to save some times, but of course I'm going to be explaining everything what I did exactly. So the first thing I did is I created a new folder, called it include. Of course you can call it whatever you want, but you have to use the same name that you have called your folder with later. So inside this folder, you'll notice that I created 4 files here: types.h, screen.h, string.h, and system.h. I'm going to go back to explain what is inside this files later, but first let me demonstrate what we will get in the end of the tutorial. After following this tutorial, what we will end up with. So I'm going to open up the kernel.c here, and you notice that I wrote down nothing. And when I compile my code here, first, before compiling it, make sure to open it as a text file and add read space A or any name here to prevent the code from stopping once there is an error or something. So make sure to add this in the very last line of the code. That will help you a lot. So now inside my kernel.c file here, unlike before, I can use some of the function that I have defined, like print, for example. We're just going to print something to the screen. Hello, this is my first kernel. And when I save this code and compile it, it prints, hello, this is my first kernel. If I want, for example, to clear up the screen before printing anything, I can use another function that we have defined, which is clear screen. So it's going to happen. We're going to be clearing the screen and then printing this line, this text here. So open up. Save it and open up build.sh. And you'll notice that the screen had cleared up and we've got our message here. Also, if we add another print here, say print, for example, this is my second text. When I compile the code and run it, you'll notice that it continued writing here. It did not overwrite what we have wrote down in the first place. Also, if I like to make a new line, we can do that only by adding the \n and save. And as you notice, a new line have created. I can also clear a specific line of code. For example, I'd like to clear up the first line of code from being displayed on the screen. I use a function I called it clear line. From line 0 to line 0, since the index starts from 0. So save and run our code. And you notice that the first line have been deleted. If I make it, for example, from 0 to 1 or to 2, for example, so it's gonna delete the first line, the second line, and the third line. Okay. So these are some basic functions that we have defined in the files that I showed you. So we're gonna take a closer look. First, let us go back to the kernel. You notice that here I added include space include dash screen slash screen.h. Include here is our folder, and inside there is a file called screen.h. So what the compiler is gonna do, or the linker or whatever it is, what's gonna do actually is gonna be looking for this file here and integrate the code needed by this key main function. Is going to integrate what is inside that screen.h file into our main program. So I'm going to open up. I'm not going to open up screen.h for right now. Let's make them in order. The first one that I have created is types.h, so I'm going to open up types.h. So these two lines tells if we have not defined this file types.h, then define it, and if. Okay, you have to always add these. They're not. You're not obliged to do this, but it is good to be organized from the beginning. So here we have defined some types. So we have defined the integer of 8-bit as a signed char. We have created a new type called unsigned int of 8-bit, which is actually an unsigned char. An integer of 16-bit, which is actually signed short. An unsigned integer of 16-bit, which is actually an unsigned short. And integer of 32-bit, which is actually a signed integer. An unsigned integer of 32-bit, which is actually an unsigned integer. And integer of 64-bit, which is actually signed long, and unsigned integer of 64-bit, which is actually an unsigned long. And we also have created a new type. We called it string, which is actually a char pointer. So as you notice here, in our file, all we did is we declared new types that we're going to be using in other files. So the next one I have created is string.h. So you notice that the string.h includes only one function. And the function here depends on these types. But these types are defined in the types.h, which means that we have to include the types.h to the beginning of our code here. And that's why we added here include space types.h. And we did not enter here the folder which is include, because both files are in the same directory. So if I minimize this, you notice that the types.h and the string.h are in the same directory. So there is no need to re-specify the directory again. Okay, so the function that we have here is a function that returns an unsigned integer of 16-bit and takes a ch, which is a string. The function is called string length, str length. I guess you understood what this function does. All it does is that it calculates how much character do we have in a given string. So how it works? First, we defined the variable I as an unsigned integer of 16-bit, and we had put a value of 1 inside it. So that's an initialization. So while ch of I++, then do nothing and repeat the loop. So what this is going to do is going to be every time adding 1 to the I, and of course checking the ch of I. So here is the ch. The ch is a string. And when the ch of I is anything different than 0, then which means that this is going to be treated as true, which means that the loop is going to continue. We're going to repeat the process again and again and again, and every time we add 1 to the I. The loop is going to continue adding 1, and repeating itself, adding 1, until until the ch of I is no longer true, which means the ch of I equals 0. And that won't happen unless we reach the end of the string. Okay? So what's going to happen? We have I, which has 1. And then while I is true, repeat the loop while I is true, repeat the loop until it is false. And then, of course, we're going to return the value of I minus 1. So we're going to subtract 1 from I and then return it. Okay, this is what this function does, is calculate the number of characters inside the string. The next file that we have created here is the system.h. Of course, this file, I'm not going to be explaining everything right now, as long as it has some assembly calls, which I'm not going to be covering on this episode, but I'm going to give you a quick review on what this function, what this file does, and what is the role of the functions here. So, inside this file, you notice that we have two functions. One is of type void, and the other is of type an inside integer of 8-bit. Since the inside integer of 8-bit type is defined in our types.h here, we have to include the types.h header. And since they are in the same directory, we do not need to type include /types. We just make it directly types.h. So the first function here is called import b, which takes one value of type inside integer of 16-bit. So what this function is going to do is going to take the port address here, and it's going to return the value of that address. Here we've got the rv function. Rv variable is an inside integer of 8-bit. We're going to take it and doing some assembly stuff to it to return. Then we're going to make some modifications in it using assembly, and then we're going to return it. Actually, what this does, these are some calls to the assembly, which is gonna connect to a specific port that we put here, and it's gonna return the value inside that port to us, which the value is always char, or an inside integer of 8-bit. You might be asking, why do we need this function? Actually, this function is pretty much important, because, for example, if we'd like to control where the cursor appears on our screen window, for example, we have to talk directly to the ports. And since there are some devices when you want to talk to them or you want to read data from them, you have to use ports. And you cannot talk to ports directly using the C programming language. That's why we have created a function here in the assembly language. Unlike the screen device, we can talk to it directly through the C programming language, because all we gotta do is to write data to a specific area of the memory, the RAM. And then the screen device is gonna keep updating its data, what is appearing on it, depending on what is inside that particular area of memory. That's how it works. But for the cursor, for example, or for the keyboard and for the mouse, it's different. We have to talk directly to the ports. And that's why we have created these functions. So this is going to read from the port, and this is going to actually write to the port. So the first argument here is the port itself, and the second argument is the data that we're going to be writing to that particular port. And of course, this is an assembly instruction, so of course I'm not gonna be explaining it, how it's work, why the ASM, what does it mean the volatile, and why it out to be here, and everything. We're gonna be explaining them in later episodes. So this is the system.h. Of course, I don't need to understand everything here, as long as we're gonna be covering everything later. So save. And the final header that we have created here is called the screen.h. I'm going to open it up, and you'll notice that this is the biggest code, the most one that has codes in it. It has not so many, but it has some functions. The ClearLine function, the update cursor function, the clear screen function, the ScrollApp function, NewlineCheck function, print ch or print character function, and the print function. Okay. So first, as you notice here, we have an inside integer of 8-bit. This is a type that we have defined in our types.h file. That means that we have to include that file into our screen.h file. So include types.h. And also, as you notice in the update cursor here, we use the output.b function that we have defined in the system.h header, which means that we have to include that header. And the string.h function, we also use this function in the print here, in the print function, so str length of ch. So of course we have to include the string.h here. So now let's start understanding what is happening, how these functions work. So the first function here, we've got a function called ClearLine, which is of type void. This function takes two parameters. The first is of an inside integer of 8-bit, form, variable called form, and the second parameter is an inside integer of 8-bit called 2. So as I mentioned before, this function is going to clear from a specific line to another line. So how this function works? First, we have an inside integer of 16-bit variable called I, which is going to take the screen width, which we have defined here, which is 80, times the from, the line that we want to start deleting from, times the screen width, which we have defined here. I haven't talked how the VGA screen works on this particular mode. So a VGA screen, think of a VGA screen in the mode selected here as think of it as a table. So a table has columns and rows. Each box you got, so you're gonna get so many boxes, box 1, box 2, box 3, box 80, and then box 81, box 82, box 83, until box 160, and then 161, etc. So all of these boxes, we've got in this big table 80 columns and 25 rows. Each box is going to handle a character, and each box takes 2 bytes. The first byte is going to take the character itself, and the second byte is going to take the color of that character. And that's why here we say the screen depth is equals to 2. That refers to 2 bytes, since each box there takes 2 bytes, one for the character itself and the other for the color. So we're gonna be explaining more in depth later, maybe in the end of the tutorial, or I don't know, but I'm sure I'm gonna be explaining them. So the I is going to take, we said here, screen width times the from times the screen depth. And then what's going to happen, also here we've got a string video memory, which is going to take this address. And of course, since this is a numerical address or an integer address, we're going to be casting it. So we're going to be casting it using string. This is just to prevent the compiler from giving us some warnings or stuff like that. So you might be asking, if video memory is a string, what are you talking about? Yeah, if we go back to the types.h here, file that we, header that we have defined here, you'll see the string is a char pointer. And since we point to the addresses in memory using char pointer, and string is a char pointer, so I can use a string instead, which is easier and more familiar for users and for programmers. So the video memory is going to be taking this address, which is the very first box of the screen. So if we got, for example, this screen, this entire screen that I'm working with, this screen actually is divided, not the screen, but the screen that you put on is divided into 80 columns, 1 column, 2 column, 3, 4, 5, 6, 7, so 80 columns, and as I mentioned, 25 rows. The very first box that you get there has this address. So if, for example, we look to the address of OXB 8001 or 8002 is going to be just to the right of it. So let's go back here. So for I, which is we initialize the value of I here, I is less than screen width times the screen depth times the 2 plus 1. This is the 2 that the user put it here as an argument. So this is going to be clearing the screen from this particular address to this particular address. That's what's going to happen. So, and of course the loop is going to be repeating again and again and again, and we add 1 to the I, and the video memory of I is going to be taken 0, whether for the character itself or for the color. So all of them are going to take zeros. So let's move down to the second function here. So this function is of type void. It is called the cursor update. And you notice that this function uses the cursor y variable and the cursor x variable that we have defined here. So we defined cursor x as an integer and cursor y as an integer. And both of them takes a value of 0 as an initialization. So what this function does, it creates a new variable called temp. It is unsigned, so it is totally positive. So what this variable is going to take is going to take the cursor y times the screen width plus the cursor x. So the cursor y, the current line, times the screen width plus the cursor x. So what is going to do this function? Actually, this function is going to be sending the location of our cursor, what it should be, to its specific port, which is OX3D4 in our case, and OX3D5. These ports are those for the x86 architecture. These ports are those that controls the position of the cursor on the screen. Of course, in the mode, on the VGA mode that we have chosen here, which is the text mode of 80 by 25 by 16 colors. So again, I'm not going to be explaining this deeply so much since it needs some advanced knowledges, but I'm going to go ahead and I'm going to go back to this later. We're going to be explaining what this shifting symbol mean, and we're going to be explaining everything later. But of course, if you'd like always to change the position of the cursor, all we gotta do is to change the values inside this cursor X and the values of this cursor Y, and then call this function, which is the update cursor. And if we make a demonstration here, I'm gonna delete everything here, and I'm gonna be using this update cursor. So I'm gonna put inside the cursor X, I'm gonna put inside it, for example, let's say 20, and the cursor Y, I'm going to be putting inside it, let's say, for example, 15. And then, of course, I need to call the update cursor. And now, when I compile the code, you notice that my cursor just went here, which is the column number, let me see. Okay, the column number 20, and the line number 15. So we just changed the position of our cursor. So let me delete this for instance. Okay. So that's what the update cursor does, and that's how to control it. Here we've got the clear screen function. So what this function does is going to be clearing the entire screen, as I demonstrated in the first in the first of the video. So if we redo that again, so clear screen, and then save, then compile. We notice that the screen is empty, there is no code inside it, no BIOS calls, nothing. Okay, that's the clear screen function. Okay, so the clear screen function uses the ClearLine function that we have created here. Okay, we said that the ClearLine function takes from and to parameters, which is from which line to which line. What it does actually, it starts clearing from the line number 0, which is the first line, to the line of screen heights minus 1. What is the screen heights? Screen height is 25. And since we want to delete from 0 to 24, so it is from 0 to the screen height minus 1. Since the counter starts from 0, it ends to the screen height minus 1. And what's going to happen is that the cursor X is going to take 0, the cursor Y is going to take 0. So the cursor, after clearing the screen, the cursors are going to go back to 0 location. And we're going to be updating the cursor to make updates to them. Okay. So we have here also another function. I called it ScrollApp, which is of type void. That means it returns nothing, which takes one argument of type inside integer of 8-bit, one argument called line number. What's going to do this function? Actually, first thing, let's start step by step. So the first thing is going to create a new variable called vidmem of type string, which is going to take the value of the screen, the address of the screen, the address of the first box of the screen, which is OXB 8000 in our screen mode. And also is going to be created a counter, which is of type inside integer of 16-bit, and initialize it with a 0 value. So we've got a loop, a for loop. So this loop is going to repeat itself until this condition becomes false. So for I, which is 0, I is less than screen width times screen heights minus 1 times 2 here. I'm going to be changing it by screen depth. Okay, so screen width times screen heights minus 1 times screen depth, so the I plus plus. So here is going to happen. We're going to repeat this process for the entire screen from the very beginning point of the screen to the very last point of the screen. What we're going to be doing, the video memory fi is going to take the video memory fi plus screen width times here screen depth times the line number. So it's gonna this what it's gonna do is gonna move up an entire line. How much times? By line number. So this screen width times screen depth means an entire line. And when we multiply it by the line number, we multiply it by how much line do we want to scroll up. Okay, so each line is going to take its corresponding line. So if we demonstrate how this function works, I'm going to go back to the kernel. And I'm going to be using this function. So first let me print a new line. And then let me print a hello. This is the second line. And then what I'm going to be doing is I'm going to be scrolling up this by 1. So scroll up by 1. And then save and compile the code. You notice that the hello, this is the second line, it's supposed to be here, just under it, but we moved it by 1 line. And also this code used to be here, just after what it is, but we moved it upwards. And this booting from ROM used to be here. So if, for example, I move the text by, let's say, by 3 lines, for example, and then I compile my code, you notice that the booting from went upwards one more time. Okay. So, let us clear this for now, for an instance, and save. Let's go back to our screen code here. So after that, we're going to be clearing from the very last line of the screen, minus 1 of course, which is from the line 24 minus the line number to line 24. So when we move all lines to the top, actually we're copying all the lines to the top. But of course, there's a copy on the bottom, so we have to delete it. And we do that by the function that we have defined upwards, which is the ClearLine sh minus 1 minus line, which is the ClearLine function that we have defined here. Okay. So, and what this does, this checks if the cursor y minus the line number is less than 0, then the cursor y is going to take 0, and the cursor x is going to take 0. So this means, actually, if we move the text to the top, of course the cursor itself is going to move to the top. But it could move off the screen. So what we should do in that case, we should make it take the coordinates of 0. We do not want the cursor to go off the screen. Else, if the cursor did not go off the screen, then the cursor y is going to we're going to subtract from the cursor y the line number. So if we move our text here by 3 lines, the cursor y is gonna subtract it by 3. So also the cursor itself is gonna move to the top by 3. And after all of these instructions here, we call the update cursor to update the position of the cursor depending on what is inside these variables, the cursor y and the cursor x. So here also we have a new function of type void. It returns void, which is nothing. It is called the NewlineCheck. What this function does actually, if the text reaches the end of the screen, if it reached, it's gonna move the entire text of the screen to the top by 1. So let's say that we later have configured the keyboard properly. So if we start writing to the screen, start writing to the screen, at a time we'll reach the end of the window. So what's gonna happen then? Will we go off the screen? No. Of course our text is gonna move up, okay? And of course not gonna move up automatically. We have to create a function that does that for us, and we have created that function, which is ScrollApp. But we need to move the text up for a condition. That condition, if the cursor y is bigger or equals to the screen heights -1, which is line 24, then we're gonna scroll up the entire text by 1. And that's what the NewlineCheck function does. So let's apply all of these functions that we have created here in the print character function that we have created here. So what this function does actually, it takes an argument of type char and then print it to the screen. So if I go back to the kernel here and use this function, print ch, let's say for example print the character A, and let me clear the screen first. So clear screen, and then I'm going to compile. You notice here that it printed the character A for me. So that's what the print ch function does for us. And this is the print ch function, which returns nothing, by the way. So first thing we made here is a string. We created the video mem variable, which is of type string, which of course is gonna take the location, the address of the video memory, of the starting point of the video memory of this code, of this mode. And of course we're casting it to a string because this is a numerical value or an integer value, while the video memory is a string, or let's say it's a char pointer. So we have to cast it to a char pointer to do that. So here we've got a switch case. It's gonna see what this switch case does. It's just like the if conditional. So it's gonna see what is the C, what is the value inside the C, and if that value is this one, then it's gonna execute this. If not, if it is equals to this one, then it's gonna execute this. Else it's gonna see if it is equals to this, then it's gonna execute this, and so on and so forth. If none of these is correct, then it's gonna execute what is set by default here. So here, if the character C, this character C that the user entered it as a parameter or as an argument to the print ch function, if it is equals to the code 8 or OX08, this stands for the backspace button. So if the user enters this value, the cursor is must move up one character back. So if I, for example, write, for example, hello, if I press the backspace key, if I press it, I'm gonna press it, I pressed it, what happened? The cursor moved back, and what is inside this space here, this one, had been deleted. And that's what should happen actually here. So let's delete this. The cursor X position is going to move back by 1. And also the video memory of the cursor Y times screen width plus the cursor X, and of course times the screen depth, is going to take 0. It's going to be deleted, and that's what's going to happen. Else, if this is not true, if this is not the case, then if it is 0x09, this is actually the tab button. And you know what the tab button does. I'm going to click tab right now, and you notice that the cursor just moved by this space. And we wanted to do the same in our program. So we're moving the cursor X plus 8, and this actually means and the modulus of the screen 8 minus 1. So this actually means that we're going to be moving the cursor X by a certain value of spaces. So I'm going to demonstrate how this works in the kernel.c file here. So I'm going to be here printing the tab, which is 0x09, so 0x09, and save. And now when I build my code, okay, just let me do it again. Let's delete that, for instance. And now when I build my code, you notice that the cursor moved here. It did not start it from the beginning or from here, it started from here. It's just like we pressed the top button, it just moved from this place to this place. And that's what that case means. If that's not the case, then if this is the case, this is the \r. If this is the case, then we wanted to just start the line from the beginning again, so the cursor X is going to take 0. If that's not the case, if the case is \n, then what's going to happen is the cursor X is going to take 0, and the cursor Y is we're going to add it 1, so we're going to jump to the next line. If that's not the case, then we're going to execute this, which is by default. By default, the video memory of the cursor Y times the screen width plus the cursor X, and all of them times the screen depth is going to take the character C. So by default, we're going to be printing the character C to the first byte, and then the other byte, which is the first byte by +1, is going to take this color, which is white, which stands for white. We can change it to any color we want. Let's say, for example, let's make it a red color on a green background. So if I compile my code, for example, let's clear the screen and print hello to the screen. And now when I compile my code, you notice that it is a red hello on a screen on a green background. So that's how we control the code. The color, so this one is for the foreground color, and this is for the background color. This one here just moves from 0 up to F, which stands for 15, and this moves from 0 up to F. That's how you change the color. You can test them all by yourself. So I'm going to leave it as 0F, which stands for a black background and a white foreground. And here again, we're adding the cursor, we're adding 1 to the cursor X each time we print a character. And of course, here we've got a condition. So if the cursor X hits the screen width, if the cursor X hits the very end area of the screen, what we're going to do, the cursor X is going to be 0 and the cursor Y is ++. We add 1 to the cursor Y. So this means that if we reach the end of the screen, we jump to the next line automatically. And the new line here checks if we reach the end of the screen. As I mentioned, the screen is going to be, the text on the screen is going to go to the top to free up some space. So we always keep updated what is the last thing written to the screen. And of course here we've got the update cursor. So we made some changes on the cursor after all of these algorithms and stuff, so we need to update the cursor to take its new position. And that's how the print ch function work. And here we've got our last function for this episode, which is the print function, which of course depends on the print ch function that we have created here. So this function returns nothing and takes one argument of type string, which is called ch. And first we've got here an I, which is of type inside integer of 16-bit, is going to take the 0 as an initialization. And for I is less than string length of ch I++. So it's going to be repeating this instruction by how much characters we have here. And if we move back, this str length function that I am using here is defined in the string.h here. So print ch of I. So it's going to be printing the ch of I each time the loop repeats itself. So this is how this this is how this code works. These are, as I mentioned, some basic functions and stuff that I have created. This is the kernel.c itself. And also I want to give you some comments, let's say, or some stuff like that. So if we go to the OS one, you notice that inside the include folder, let's go to this one, for example, screen.h, all of our functions are defined in the screen.h itself, which is actually not good, but I wanted to do it this way, so because we're not concerned about this stuff, okay? We're concerned about the operating system development. So this type of declaration of functions is called the static functions. And don't be confused with the meaning of the word static, as long as it might not mean the same thing that you used it to mean with the higher level programming languages like C# or some programming languages like that. Because the word static means, here in this example, means that this functions, for example, which is the clear screen, when we call this function from our kernel.c file, let's say we called it 10 times in our code. So what's going to happen is that this function is going to be written and rewritten again inside our kernel.c 10 times, which is going to be generating so much code, so much repeated code, which is going to, in the end, generate a very big size of executable. So if I go, for example, OS1 to the kernel file and see its size, oh, actually it's still small, but again, it's 6.7 kilobyte. It is not so small. Okay, so it is better to define your functions here, which means that you, for example, you type in void update cursor, and then you add a semicolon here, and of course you add external keyword here. I guess that I spelled it wrong. I don't know. Okay, anyway, you add the word external here, and you just delete all of this stuff. And where you define this stuff, you define it inside the screen.c or the C code. Okay, so here you tell that there is a function called update cursor, which is elsewhere. I don't know where, but it is elsewhere. It's going to be defined in another place. Go search for it, and each time you need that function, you do not need to rewrite it again. Just go to it and execute it from its binaries. And of course, after creating the C files, you have to add them to your compiler. Here, go to display, and then we want them to be compiled, so we add the word GCC and the same parameters here, and you change the kernel.c by the file name and then the final name .o. So that's how it goes. Some friends commented that I have not used some arguments here in the compiler that will prevent the GCC from thinking that the function that I have defined here, that the GCC is going to be using the function defined by the system itself. Actually, I did not use those extra parameters like freestanding and no stdlib or no some stuff like that. I didn't want to use them because simply I wanted the tutorial to be as simple as possible. You know, each word means a lot, especially for new programmers on this field. And that's why I'm trying just to keep the code as simple as possible. And also, in the previous tutorial, I told you to install the gedit editor. While I open it. This is the file that I showed you in the previous editor. Some people commented that how can I install the gedit while I'm editing the text on the gedit itself? Well, you can do this on, you can install the gedit on its own directly using the terminal and then open it and enter all of these commands. Or you can do this on basically any text editor. Okay, that's simple. Okay, so thank you guys for watching. If you have any question, suggestion or comment, feel free to leave in the comment section below. Thank you for watching. Don't please forget to subscribe to my channel, and don't forget to share these videos, and also you can check my other videos if you're concerned. I'm gonna be presenting new tutorials and new episodes later, so don't forget to check the channel sometimes, and see you later.
Thank you guys for watching. You've been with Nilal Abidi from the Iknow channel. Don't forget to subscribe and see you guys later.